Hi, welcome back to our last example for 4.3 reciprocal trig ratios. In this example, we're going to determine angles in the unit circle that have a given reciprocal trig ratio. Okay, so it says determine two angles between 0 and 360 that both have a cosecant of -2. So what that means is, I'm just going to draw a quick unit circle. Okay, it's not perfect, it doesn't have to be. So it says find two angles that have a cosecant of -2. So first off, cosecant, I'm going to write out the first one angle as theta. It has a cosecant of -2. So I don't really know what to think of this because it's a reciprocal trig ratio. So what I like to do is kind of just like in the last example, I like to take the reciprocal of both sides to rewrite it. Okay, so that's what I'm going to do here. The reciprocal of cosecant, well, that is just sine. Okay, so if I take the reciprocal of this side to get sine, then I got to take the reciprocal of this. The reciprocal of -2 is going to be -1/2. Okay, so this makes a little bit more sense now. Okay, I'm going to draw my two terminal arms. Okay, I don't know the angles yet, but I know that sine has to be negative. Okay, so I first write out the cast rule. This tells me where the trig ratios are positive. So sine is positive up here for S, and under all, A for all, it's also positive. So if my terminal arm is here or here, the sine ratios are going to be positive. Notice we have negative. So that means they actually need to be down here, both of them. So I'm just going to go ahead and I'm going to draw those. So I have the first one here. Okay, I don't know this angle. And my second one is here. And it's congruent. It's going to make congruent triangles. So the one here and the one here are going to be congruent. Okay, so this angle in here, these are essentially the same, these two angles. They're my reference angles. So remember, reference angles are always the acute angles made with the x-axis. Okay, the angles in standard position, that's the actual angle of the terminal arm. It's going to start from the x-axis and rotate counterclockwise. That'll be the first one, and then this will be the second one. Okay, how am I going to figure that out? Well, it won't be too hard. I just need to know what these reference angles are. Okay, that's actually step 2. So this example is a lot like the last one. We're just finding both angles. So it says determine the reference angle. So what I can do here is I can actually use my calculator to help me with this. So let's go ahead and solve for theta. So we'll see what the calculator, what angle it gives us. So sine inverse of -1/2. So -1/2. It's telling me that I have an angle of -30. Okay. So it's actually giving me one of the angles, one of the answers, and it's given it to me as a clockwise rotation because it's negative. So what I'm going to do here is I'm going to write theta equals -30. Okay. So normally the angles measure counterclockwise this way for positive. -30 means it rotates this way. So what that is actually telling me is that there's 30 degrees in here for this terminal arm. So because of that, I know that this also needs to be 30. I don't write -30 in here because I'm actually just writing the size of this angle and the size of that angle. So I want to get my answers, my angles in standard position, which means they always need to be measured from the x-axis to the terminal arm. So I'm actually looking for that. So what would that angle be? So that angle is going to be, so my first one, I'll write theta 1. It's going to be equal to 180 plus that extra 30 degrees. So 210. Okay, my second angle, I'll do this one in blue. It's from the x-axis rotated counterclockwise all the way to the next terminal arm. That's going to be theta 2. So that looks like it's almost 360. It's almost a full circle. It's just short 30 degrees. We can write it as 360 minus 30, which is 330 degrees. So those are my two angles that have a cosecant of -2. How can we check this on our calculator? So that's actually a really good question. I'm glad I brought it up. But you might have been thinking that. So how can we find cosecant? So Desmos is great. It already has a cosecant button right here that I can use. Your calculator, you might have to hit like a second button. So it probably might be a little bit hard for you to do that, but I can definitely show your calculator in class. But what you can do though, if you don't want to do this here, like check your answer that way, you could always check it with this expression too. So it'll be the same thing. So if you put these angles in to theta, both of these, if you put them in for theta, you're going to get a ratio of a -1/2, and that actually tells you that they're correct. Okay. Since Desmos has the cosecant button, I'm going to do it that way. So cosecant of 210 should give me -2, and it does. I'm going to repeat this. Cosecant of 330 also gives me -2. Okay, so you could check using this. If you don't want to use those reciprocal trig buttons on your calculator, no problem at all. Plug your angles in for theta and see if you get -1/2. So let's try sine of 210. I should get -1/2, and I do. And then sine of 330, also get -1/2. Okay, and you can see how sine and cosecant are reciprocals of each other too. Okay, so that's actually it for this lesson. Hope you guys have found this helpful. I will see you later.